hello everyone, good evening. We're Powerbooks Unplugged.
Half of it.
Half of Powerbooks Unplugged actually. We tend to be between 4 and 6 persons. Tonight we're only 3, so yeah. Anyway, we'll just do it in 3 persons. The title of our talk is what you can see here already, I hope. Distributed persons and paranoid letters. Right. So when you consider the role of code, traditionally code tends to be technical solutions to mathematical problems.
Instructions for machines.
Or instructions for machines, or tools to do tasks for you. There's also an alternative view of considering code a form of literature, which you can also see in things like code art or in quines, which are programs that can actually write themselves back as code. And we also consider code to be sort of a double thing between this view of literature and the enactment of ideas, being either the realization of something that you're thinking about or a simulation of something that could happen in the real world but that doesn't work, just sort of happens. So,
yeah. So we have a double interpretation. First of all, we have code sort of describing sound, and at the same time this code makes up the sound. So what you get is you continuously go back executing the code and listening to it and refining it, and actually what you see as text becomes very close to what you hear in your mind. It sort of mingles.
Yeah, one unit of what we are dealing with while we are playing in the group is we could call it micro-composition. Like, of course, we don't have the whole composition in one, like, yeah, that would be tape music perhaps, if you perform electronically and have the whole thing. Or, yeah, the units that we have are a bit more compact, rather small. And here we have a sort of inspirational example from 500 years ago by Athanasius Kirchner. This is actually not a piece of poetry, but it's according to him a way to explain how echoes works. Like it's a tractate about acoustics, and he gives this list of in Latin of words that follow each other, and it looks very algorithmical, and so of course do our codes be algorithmical and make some aesthetical output.
So if you so the kind of musical structures that we're working with, we consider them to be miniature algorithmic compositions that go between different scales, which are basically time scales, scales of musical time, if you want to put it that way. So the micro time scale would be things that happen so quickly that you don't perceive them as individual events. So if you have, say, 500 very tiny snippets of sound happening in half a second, you wouldn't hear the individual things, you would hear them as one cloud of things. That would be the micro time scale. The meso time scale would correspond to things that you would usually consider to be melodies or rhythms or things that consist of individual notes, and the macro scale is everything that happens above that. So larger things like phrases, parts of pieces.
Music. Yeah, we like to call these codelets, which are code, but not an entire program that can run from one end to the other and produces a defined output. It's just little parts of code that contain or that produce some sound of one of these scales described here, and it's also the units of code that we exchange within each other, because we have this wireless network running between our computers. We'll see that later.
It allows for communication quite easily.
So it's a, you know, it's a mouthful of code that is quite easy also to read during the performance. And this can be just a single sound, or as Alberto said, a microstructure that is perceived as a single tone. It can be a longer phrase which has a defined shape, a sort of gestalt, a spiraling thing or whatever else, and yeah, or textures that are
textures that run for longer times, and that where it's interesting to be able to go into them and change them while they are running. So to go back and forth between the technical concepts and the aesthetic ideas, the topology of communication that we use is we're usually between 4 and 6 players. Since today we're only 3, we decided to reduce the lower limit a bit, so on average we're still legal. Basically every player has a laptop with a client and a server program running on it. Super Collider is split into these 2 parts, with the client being the logic machine that creates musical structures that unfold in time, and the server is the program that does the sound synthesis. So this exists on all the machines.
The client is also the part that you look at, where the code is written, executed, exchanged, etc.
It's the physical part of the music, and the server is the rendered.
The audible part of it. So for every player, you have this structure that the client program of every player can talk to both the client and the server of the other people. So we can both the text gets sent around to everybody who's playing, and the sound events can get sent around to everybody that's playing.
It's not the audio that is sent around. Maybe that's important to say. We don't send audio between each other because each computer can render its own audio, but we send descriptions or commands to start, stop, or modify audio. And so this means that I can play a sound on his computer, but it also means that I can send him a message that he might accept or not, and play a sound or send back to me.
So to go back to the aesthetic idea of distributed persons and purloined letters, if you consider the history of technically mediated communication, you could say that letters existed for a very, very long time. In antiquity, letters were being sent back and forth and took pretty long times. The next major step, you could say, would be the digitization, or the reduction to a set of symbolic representations by the typewriter, and eventually the telegraph, which
speeds up the proliferation of the communication. And now we have a sort of computer can be seen as a sort of mixture between a typewriter and a telegraph, with the network that we are employing. And this letter aspect is quite important to us, as we are sending these codelets around and modifying, and everybody gets them sent back, which, yeah, we think of it like a conversation. Actually, it's not so much of a free jazz improvisation performance, but we tend to keep it like a conversation, which can also be, yeah, very interesting also for people that are not actively taking part in it.
So it's like polyphonically circulating letters, if you want to put it that way. Okay.
Back to technique.
Yeah. Super Collider users might be familiar with the objects that are written down here. We use placeholders called proxies mainly, and there's for synth processes there's something called node proxy, also called ndef, and for routines there's a task proxy or tdef. For patterns there's the pattern proxy or pdef. So basically an ndef is an abstraction for something that's running on the server really, and a tdef and a pdef are things that are more client oriented, where you actually communicate with the node proxies or the ndefs. That's how it's done. And what it makes you do is change a running process on the fly. That's the important thing about it.
Yeah, this is actually the one thing that suddenly in Super Collider allows us for easy live coding. You can imagine this is the proxy is a container that will always stay the same, I can create it, and until I thresh it, it stays the same, but at any time the content can be exchanged, and this proxy class actually does everything for me. I don't have to care to empty the bottle and fill it up again. I just say what I want next. It would like crossfade one sound into the next one.
Okay. So just to show you tiniest little examples, in this extension to SuperCollider called JITLib, proxies are organized by names and they stay in memory. So you have this problem of how do you remember all the stuff that you've made by name and keep track of what's going on. And for that we've come up with this concept of the disposable GUI, which, to show you quickly, you make a GUI this shows you all the stuff that we played in rehearsal earlier. So there's all kinds of different tasks, and if I put one...
Basically just a list of names with a few buttons to start and stop these tasks.
So if I put in a new tdef with a new name, it comes up here. And if I give that same tdef something to do, like play a little structure.
Well, now it's defined, but it has no content. It's just there as a name. It has its memory place. I can try to start it.
So if I play this, you can see that I can see that it's playing, and I see when it stops. So I have some kind of idea of all the stuff that's going on. If I'm managing like 20 things going on at the same time, I don't have enough memory for that. So
I can restart it at any time.
So why not let machines do this? And you can throw the GUIs away at any moment. Nothing depends on them, so it's a very convenient way of keeping track of what's going on. If you want to look back into what has gone on before, there's an object called history, which actually, if I do something, if I write a little program and bring up the history window, it should actually show me, let's see, probably this one has updated. I can see all the earlier lines of code that somebody executed, and I can see all the stuff that the other people have done that got sent around to me. So this is how the communication really works. Okay.
Basically, the computer cares about dispatching everything that I execute on my computer to the peers in the network. So everybody has access, and this is the interface to go back in history and see what's happening, has happened when. It also would allow for complete playback of our performance, because it's time tagged and would sound pretty exactly the same at a later point in time.
If you want to look into the future, or to consider the future, it's hard to see things. You could send messages through history, but it's kind of hard to pay attention to that and actually notice important things. So for that we have the shout class, which I think is sort of self-explaining. We're probably over time by now already, right? I'll try and speed up. So to get into the aesthetic considerations, we really enjoy working with deliberate constraints. Some of them are physical.
Yeah, well, of course we use a laptop as our main instrument, and this brings certain constraints, and the most important constraints would be the low volume and the fact that you don't have any bass, nothing below 300 Hertz. So we use this in a creative way, and even the distortion that you get by almost getting to the 0 dB, the clipping sound we use in our own way.
Yeah, this is another set of constraints. We weren't sure whether this was aesthetical constraints or strategical constraints. Anyway, what we have, we limit ourselves to microsound as the main material. On one hand, because we like it, and because it's very interesting to mold. The code as our main interface, of course, is a big limitation. If you will hardly find any serious musician on the stage doing a performance in a concert place acting with code, because it's very slow. That's a big downside. But on the other hand, we really like what we get out of it is perfect flexibility. Like at any moment we can decide to change this or that detail of the process, which elsewhere would hardly be possible, because the GUI or some hardware interface only allows us to control a very well defined set of things.
Yeah, and it's easily scalable, of course. Over time, you can make something very small, like we said before. Leverage between the micro, the meso, and the macro timescales.
Okay. So we find that this creates interesting performance situations. You don't need to be on stage with this. It's very natural to be in the park. So we consider the laptop to be sort of the equivalent of the folk guitar in the 60s. Probably more people play laptops now than guitars. I still haven't checked the statistics on that, but I'd be curious about it. So if somebody has data about that, tell me. The laptop, it's interesting to also take the laptop serious as a physical object that exists in history right now. We don't know whether laptops like that exist in 10 years, so we may actually have to keep them for historical performance practice. And we find that low volume is really interesting because it creates a different kind of attention. Okay. So, okay. The implications of using microsound or granular synthesis, which is sort of an equivalent to that, is that it's really very almost infinitely moldable. You can change so many details about it. And the idea of particle-based synthesis of using little snippets of sound is they really spatialize very well. You can hear very nicely how they jump between different physical sources.
That's also the reason why we are not sitting in front of you all together, because you wouldn't hear much different. We tend to mix with the audience so you can hear the sounds coming from different places.
Okay. Okay. So it leaves a lot of space for many layers of things going on, and you get lots of transparency almost for free. We find this similar to sound ecology, and as bioacoustics would consider it. So finding spaces in time and in rhythm and in frequency where you can hear your own little thing going on. Okay. So we think code is about modeling ideas and not about it adjusting machines, and it's nice to have multiple levels of access. And the main thing is that the difference between how we read sounds and imagine they will be, and what the process actually sounds like, and then thinking about that and reacting to that, this is what we find really interesting. So we'll start playing now. Thank you.
Press escape.
you.